All right, we're recording. Cool. So, can you guys see my screen all right? Good.
Yep.
All right, so I first want us to go around and just give a couple of introductions. I want you to tell me a little bit about your background, what you hope to get out of this session, what you hope to get out of a collaborative learning group in general, and then if you would indulge my cheesiness, I'd like to hear a name of a person that you love a lot. um, so yeah, I'd like to go last. So if, Josh, would you be willing to go first?
Yeah, that sounds fine. Um, so I'm 30 years old. I was a high school teacher for the last several years. My academic background is primarily in physics. So I have a bachelor's and master's in physics. I've been teaching high school computer science, and I just quit that job to transition into blockchain. My intentions here are twofold. One, of course, want to learn the pi calculus, and then I'm also interested in the social aspect of just getting to know all you guys and kind of getting dialed into the community a little bit more. Um, yeah, I guess that kind of answered the second and third one. And then, okay, a person I love a lot. Should that be someone that like you guys know of, or one of my family members, or
No, yeah, it could be anyone.
my girlfriend's name is Julie.
Great, thanks. Glenn, could you go next?
Sure. Hi. My name is Glenn. I'm a software developer for many years, basically my whole life. Last summer, I bumped into RChain. I'm here in Seattle, so able to meet Greg and the rest of the gang here. That's where I learned about the pi calculus and found it just fascinating. Very simple, yet very potentially powerful. So I've been teaching myself it for a while. And so I'm interested in diving in deeper with people because I've been all alone doing it so far. And someone I love is my wife, Karen.
Great, thanks. John, I don't know if you're free and available for introductions, or I know that you said you had some stuff going on this morning, so you might just be able to listen in. So, Dror, would you like to go next?
Yeah, so my background is I've done a comp sci in uni, worked in the tech industry for a few years after. Currently more involved with my family business, so I'm programming less. Thing I'm trying to get out of like these sessions is I'm interested in Rolang. I want to develop like on RChain in the future, so hopefully I will like know Rolang better by understanding the pi calculus version of Rolang. Yeah, I'm not sure who I love as a person. Like my dad, is that okay?
Yeah, that sounds great. Thanks.
Cool.
All right, Mateus, is that how I pronounce your name? Would you be able to go?
Yeah, it's like 99% right. Mateusz.
Mateus. Okay.
Yeah, the ending is harder. Okay, so my name is Mateusz. I'm 28, and I've just joined Pyrofex as a developer. It's been like 1 week only so far. So what I hope to get out of this session is I familiarized myself with. I refreshed lambda calculus. I read on the pi calculus few papers and the raw calculus. I want basically to understand raw calculus better as principles to be able to develop the Rolang with more confidence because it's pretty new stuff for me. So yeah, I think I got the basics. I got the basics, but I want to like fill possibly missing gaps. And the person I love is my girlfriend Sylvia. Yeah, thank you.
Awesome. Thank you so much. Thanks for joining. Andre.
So here I am. Hey, just didn't remember to put on my mic. I'm Andre. I am in Berlin. I have a pretty diverse background. So I started studying computer science and psychology a while ago and then dropped out because it was because I actually basically found a job here in Berlin in product design, experience design, which led more into like a creative problem solving thing. I have been working on that for the last 3 years. And yeah, I want to learn about the pi calculus and the background of it, because I understand the potential of what Greg is building up on a surface level, but I also want to understand it on a deeper level, which will mean that I basically want to understand the potential of it and where it can be applied in different areas in science or the world, basically. And yeah, it's also super fun to learn together. It's learning alone is more difficult. And the person I love, it's quite tricky, I think. It's a little bit like the row calculus, right? You have all these like love channels, and they're in parallel. They're also competing a little bit. I don't know.
I'm just asking for a person, not the person.
A person.
Yeah.
A person.
It could be yourself if you want.
My right hand. No, I'm just kidding. Probably, let's say, well, yeah, let's say my dad. He's pretty cool.
Great. Thank you so much. Jonathan, you're up and you made it. Are you able to give yourself a quick introduction as well?
Sure. I have a very polymathic background. I have had about 8 careers, ranging from evolutionary biology at Yale to information architecture at Amazon to ecological economics to being a professional musician and record label owner, biostatistician, epidemiologist. My first programming language was APL, of all things. I am very interested in really understanding, at least at a conceptual level, the pi calculus and Erlang because of my engagement with RChain. And I will say, because we're going to be starting with monads today, my favorite person is Gottfried Leibniz.
Nice. Great, thank you. Asheinart, is that your name? Would you like to introduce yourself next? Okay. What about Phoenix?
Hi, do you hear me?
Yeah, I hear you just well.
Great. Yeah, I joined through the Blockio group. My name is Udo, normally. And yeah, why I'm here now, right, in this tutorial is because I want to understand the p-calculus in order to join the group developing on the Erlang basis with smart contracts. And yeah, my background is actually scientific. I studied, I'm something like a career changer. I started with energy and environmental technologies as an engineer, and then more and more I did computational fluid dynamics, where I get more and more involved in C++ and developing my own source codes. And yes, that
Awesome.
led me now to this point here with you.
Okay, sounds good.
Yeah.
And then
Hi, can you hear me?
Carl, you able to introduce yourself as well?
Sure, I'm Carl Schrodel. I'm a computer scientist. I work for the U.S. Geological Survey. I'm a friend of Jake's, and what I'm hoping to get out of this session is to figure out what the heck Jake is talking about. He's talking about all kinds of calculi and all kinds of RChains, and I want to know what he's talking about these days. I'm also interested in seeing the stuff that we're talking here can be used to help build election systems. I work in I volunteer on an open source project called Pivot Libre that is just in like a early prototype kind of a phase. So wondering if that applies there. I hope to get out of the collaborative learning group More interactive learnings than just the readings. I don't learn well purely from readings. And then the name of a person that I love a lot is my wife, Becky. That's kind of cheating, I suppose. I'm going to say also William Playfair, who is like an engineer and a visualization specialist and a scoundrel and just generally super interesting. He's like the person I would want to resurrect from history to meet.
Awesome. Thanks for coming, Carl. Yeah, thanks so much for everyone for joining and your introductions. Did anyone not get a chance to introduce themselves and want to at this point?
Hello?
Yeah, hi, I can hear you.
Hi. Hi, Jake. This is Andreas. We met at the ArtChain conference. And so my background is, sorry, earlier I didn't get my mic to work. I hope.
Oh yeah, no problem. It's good now.
So my background is I'm a Java programmer with a long-term interest also in Scala. And just a few days ago with the ArtChain conference, I dived a little bit deeper into ArtChain and the Rolang, and I'm very interested to see how the PyCalculus foundations and all the stuff fits together with the implementations. And I'm really looking forward. I haven't done this kind of collaborative learning group. Yeah, and so I'm interested to see how that works out.
Awesome, me too. What about a name of a person that you love a lot, if that's okay with you?
That probably goes to my whole family, like my wife, my daughter, and my son.
Great, thanks. Yeah, awesome. So I'm Jake. My background is in electrical engineering and computer science. I got a bachelor's degree in that. And then sort of did some data science stuff with healthcare data for a while, and then quit that job about 1.5 years ago to go into blockchain full-time. Found ArtChain pretty soon after that, and was like, what is Greg talking about? There's a lot of math stuff there, and I don't understand any of it. And I don't know if this is like one of the new crazy guys with a blockchain project trying to make a lot of money, or if there's something deep and interesting here. And through the past 1.5 years, I've found it deep and interesting. So also the name of a person that I love a lot is my dad, Jeff. And so out of this session in particular, I'm hoping to be able to present, in a review-like format, almost the whole first 2 chapters in an easy to understand fashion. And I don't want you to have much math background for it. And out of the collaborative learning group in general, so I actually haven't made it through the whole paper that I sent you. I understand pretty well about up to chapter 4. And this is when I attempted to read it about like 8 months ago, and I haven't gotten that far again lately. So I'm hoping to get farther this time, and I'm hoping to get farther with the help of you guys. I'm also hoping to just sort of build community. Have this group go where its interests lie. Hopefully have us build some cool stuff, and hopefully also come out of this with a set of education materials that can be used and modified for other purposes. So yeah, that's everything there. I guess I should probably explain a little bit why I chose the PyCalculus tutorial paper as the first thing that I'd like to attempt to go into together. So this is a paper that's recommended by Greg and Mike Stay, and it's sort of like one of the canonical pieces of the PyCalculus. Milner invented it. Milner wrote this paper. So coming highly recommended from them, this was sort of my first dive into ArtChain and starting to learn Rolang and all that. So I'm hoping that this also serves as a good diving off point for everyone else. I also think it sort of allows us to go in a couple different directions, right? We can kind of go up the stack towards Rolang, or we could go down the stack towards like language definition tools and proof assistant tools like K-Framework and Coq and Isabella and stuff like that. So I think that's kind of a cool place to start for that reason as well. So yeah, with that, let's get into a summary of the first two chapters. So PyCalc at its core is a way to describe concurrent computation based on the notion of naming. So concurrent computation, I think this quote is pretty good. It's about many agents that are all active at once and can influence each other's activity on the fly. We could treat these agents as Lambda Calc's functional computers receiving arguments and producing results. So, you can think of, independent entities walking around, being able to process things on their own. And then if they need to share something or synchronize across some event, then they can do that. And so the PyCalculus is a language that can describe those sorts of interactions. So yeah, here's another quote from the paper: a way of describing and analyzing systems consisting of agents which interact amongst each other and whose configurations or neighborhood is continually changing. Is there a question?
Can I ask a naive question? Why is it PyCalculus? Why Pi specifically?
I don't know.
The Pi stands for process.
Yes, Pi stands for, is P for process? I'm not sure. That's a guess.
Yeah, I think that's right. I remember reading that somewhere too, but I don't remember where.
Cool. Yeah, awesome. And then
okay, and similarly, why lambda L or lambda calculus?
I don't know. So another funny thing.
Okay,
yeah. No, they're good questions. Thank you. Yeah, another funny thing about this for me is I don't really have a formal or good working knowledge of the lambda calculus. I heard about it in undergrad. It was sort of like adjacent to stuff, but I never really had a good formal introduction. So I think I'd be, for process calculi wise, I'm more comfortable, or computational calculi, I'm more comfortable with the PyCalculus than the lambda calculus, which might be kind of unique. So I'm hoping that you guys might be able to help me out with the lambda calc a bit. So we get to this notion of naming aspect. And sort of in the introduction, Milner gives sort of some ideas of why he chose naming, or why naming was a natural fit for him describing these concurrent phenomenon in computation. And so here are some of the reasons. Naming strongly presupposes independence. It's natural to assume that the namer and named are coexisting concurrent entities. We all have names here. We all sort of are existing separately with our own thought processes, and we can communicate and synchronize across things. But when I'm using a name for someone, I'm sort of recognizing their independent identity. Naming is inextricably confused with the act of communication, right? So when we want to talk to someone, we call their name. Naming is used to locate and modify data. This one, it was a little bit harder for me to think of examples. I don't know why, but I think the best one I could think of, and let me know if you have other good ones, are if you say wanted to find a line of text in a textbook and you wanted to change it, right? You'd call up the location of that line by saying the name of the page. It's on page 2, and then is maybe the second sentence in the third paragraph down, and you've just sort of located a piece of data that way by giving it sort of this abstract name that doesn't really contain the meaning of the data. And then you could use that to modify it as well.
I would say maybe that so I'm a non-native speaker, as you might have heard, but it's interesting to put the phrase on naming. If you think of naming, it's a similar concept as addressing, then you can say addressing is used to locate and modifying data. And
that's a good point.
Yeah, like a pointer or a URL.
Exactly. Like address and names. So you need some kind of way to formulate your direction, right? And this is basically addressing or naming.
Yeah, awesome. Thank you. Yeah, that's helpful. That's a great example. And then it sort of gives you the ability to treat, or in the PyCalculus, they treat data access and communication as the same thing. So the URL example is a great example again here. Data is a special kind of process, and this is taken much further with the row calculus, but we won't get there now today. In the row calculus, there's sort of minimal distinction between names and processes, and you can sort of turn one into the other. So then one of the also more interesting points about the PyCalculus is when you're naming things, you're not actually naming these independent processes. What you're naming are channels on which to communicate. So I thought it was pretty interesting that when asked to give a name of someone that you love, most of you gave not just a name, but a relationship qualifier as well, right? So I think that this sort of gets at the notion of, naming is based on a relationship, or when you give a name, you're giving a name based on more of a relationship than the true essence maybe of the identity on the other side. So yeah, any questions at this point? Or what questions do you have at this point? All right, we'll move on. So the monadic PyCalculus, there's two entities. There's names and processes. These things are distinct. Names are usually presented with lowercase letters, X, Y, Z. They're the base element of the calculus. There's no way to construct them. They just exist. There's infinitely many of them. Sort of any identifier that you can think of pretty much is a name. They don't have to be structured in any way. Yeah. Then there's processes. It's usually presented as uppercase letters like P, Q, or M and N. And processes that are not zero, which is also a process, which is the empty, stopped, do nothing process. And processes that are not sort of equivalent in behavior or structurally congruent to zero have to be constructed using operations, atomic actions, or prefixes, or maybe another ways that the operations are named in this paper. And those operations or prefixes that go on top of a process that build up from the zero process, those involve names. Please interrupt me at any point if you have a question. All right, so are we comfortable? Processes and names, uppercase letters, lowercase letters. Then there's the zero process, which does nothing.
Yeah, so far so good. Cool.
All right, so here are the prefixes or atomic actions. They're also labeled as pi in the paper. The pi of the PyCalculus, sort of these are the real operations that are at the heart of the PyCalculus. This is what you can do. And what you can do is you can output a name or you can input a name. So those are the two operations put here. So this first one here with the X with a bar over the top of it, and then a Y in parentheses after it. What that means is output the name Y on the channel name or link named X. So yeah, let's for now. The different sort of names for this X here, calling it a channel, a name, or a link that's named X was a bit confusing for me at first, but you can really think of all these terms as synonymous. So just sort of pick the one, I guess, that fits your situation when you're talking about it. So when we're outputting on something, I like to call it a channel usually. Yeah, Joshy, you have a question?
Yeah, well, so I was curious. One of the things that I read in the paper was he was using the language subject and object for X and Y. And I hadn't encountered that in the RChain community. And I wondered if that's just a bit of language that we happened to not adopt, or if that's specific to this tutorial, or if it's actually has some specific meaning that like doesn't exist either in the Rho calculus or in Rolang.
Yeah, that's a great question. And I don't really know the answer to that question. You're correct in that I haven't also heard the term subject and object being thrown around in Rolang and the Rho calculus, but I think that they would apply.
That was the impression I got too. Sometimes pieces of language just don't make it over to new communities or circles or whatever.
Yeah, and I mean, things do get a little bit different. So when you have the monadic pi calculus like this, where you can sort of input one thing or output one thing, you know, it's easy to identify subject and object. But if you have an input like you can have in Rolang with sort of multiple things being input and being bound to multiple channels, right? It's less clear. It's not all of the stuff in between the parentheses, I don't think would be the object. Yeah, so I think that might be another piece of it. Okay, so then the second form here is just a name without a bar over the top of it, and then another name following after in parentheses. So, oh yeah, so I should mention that these X and Y's sort of are stand-ins. They can be any names. And so what this means is you input some name from the channel link or name X, and then you call whatever data you receive, whatever name you receive, you sort of now have another nickname for that, which is Z. So this is sort of like, you know, defining a variable in a programming language and then you know, modifying it and having it be in scope for the rest of your code.
Hey, Jake.
Yeah.
I think in the paper for the output, you don't put parentheses for the name.
Oh, is that true? Okay.
Yeah.
Yeah, no, I think that's right. So thank you. I'll correct that in my slides. But yeah, so that, I think I did that for everything in this slideshow right now, but I'll correct that later. Thank you for bringing that to my attention. And then every
actually.
Hmm?
I've got another question actually. Is this the top line there, the like X bar Y? Is this, how well does this map onto the Rolang syntax of like X bang Y? Is that the same thing, just different notation?
Yep.
Okay, cool. Thanks.
It's hard to write a bar over the top of something in text. Yeah. Yeah, so every process.
We might see a bar, a bang, exclamation mark later in syntax, and it's actually not the same as Rolang, so we should call that out.
Yeah, I saw that one too.
Yeah, that's not the same one as, yeah, we'll see.
So this one here, the overbar is Rolang's bang.
Yeah.
Yeah, okay. It means write or send on that channel.
Thanks, Glenn. Yeah, every process starts out as 0 and gets constructed by adding prefixes onto 0. Okay, so then there's a specific type of process called a normal process. And normal processes are usually presented as uppercase letters that are not starting at P and Q, but at M, N, and L. Those are what I used in this presentation, and then M and N are sort of what are used in the paper. So when we're constructing normal processes, we're also constructing processes because a normal process is just a type of process. And there's a couple ways to do that. So 0 is a normal process. You can take one of those productions, one of those pies, those prefixes, atomic actions that we just learned about, and you can prefix that to any process. And note that that is any process, right? So if you prefix one of these things to a non-normal process, you get out of that a normal process. And I should go over the intuition about what some of these things mean. So the zero process, the stopped or empty process, does nothing. And then the process construction below, where you have this prefix dot and then a process, this means that this whole process is going to wait until the action associated with this prefix, either an input or output, finds its matches, and that communication happens, then the process P will continue. We can get a normal process by adding two or more normal processes together. So this notation, summation notation, is another way of saying the same thing. I'm going to go through the summation notation real quick for anyone who might be new to it. So down here, we have an element or label I in a set large I. And so this means that we just have a bunch of labels of some amount. And then we have a bunch of normal processes that are sort of designated by a label that's in that set. And then what we're going to do is we're just going to add all of these together. The summation notation means that take everything that's sort of inside here and add plus signs between them all. So the plus signs in this case, what they mean is that sort of either n, the prefix associated with n, or the prefix associated with L will run. And then once that happens, the rest of the things in the summation get deleted. So this is saying, if I have a normal process M that's constructed by adding normal processes N and L, either normal process N will run or normal process L will run, but they both won't run. Any questions? Or what questions do you have?
The summation part's clear, and you helped me understand the plus sign operator here too. One thing I'm still not 100% sure on is what is the difference between just a general process and a normal process. So like normal processes are a subset of all processes, is that right? And then what makes them normal?
Right. So so this is what makes them normal if they hold to this form here on this page.
Okay.
But then the
I.P form.
Yes. Yep. Mm-hmm.
Okay.
Or pi.p plus pi.p plus pi.p of different pi's, or the null process. So the intuition that I've sort of gathered behind what a normal process is it's sort of like your independent entities that are acting. So there's no concurrent behavior in a normal process. It's sort of one agent that's here, and it's either like trying to listen on some things or trying to send on some things, and only one of those actions will take place, even though it might be listening on many names. It will only receive something at one of those names, and then it will sort of continue as that sub-process that received it.
Okay. Got it. That helps a lot.
Cool.
I like to map it to like what we would write as a normal program today, like a hello world program or something that's a straight traditional program, not a bunch of programs put together, but just sort of a straight. It's a rough mapping in my mind.
Yeah, got it. Cool. Thanks a lot, guys.
Yeah. What other questions may you have about this slide? This is important stuff. So if you don't understand any of the notation, please speak up. Cool. All right, so now we'll get into the fun stuff, the not normal processes, the weird processes. So one of the way that we construct not normal processes is we have two processes of any type, and we put a bar in between them. What this means is that we're going to be running both of these two processes at the same time, concurrently. So a communication will be able to happen between them if they're both if they have a listen and a send on the same name. There's this bang P, which is a replicated process. So this means take P and run an infinite number of copies of it concurrently with each other. And then there is this new name in P. So this is saying new name X in process P. So what this means is that it ensures that X is a name. It sort of is a label for a name that can only be used by process P. So it's constructing a brand new name that no other process has access to unless it's given access to in P. Is that clear? Cool. So that's it. That's all of the PyCalculus. That's how you construct processes. Let's go over some examples that are in here. All right, so here's some of the examples that were presented in the book. I think I'm not going to go through all of these right now because we're running a little bit short on time. The first one here, we see there's a send on X. There's a process here trying to send on the Y on the name X. There's a process here on the right side trying to send the name Z on the channel X. So there's like sort of a contention for the resource output of X there. And then there's a process here that is listening on the name X, getting whatever it receives, putting it into U, and then doing some other stuff. So, and these are all running in parallel, or they're all running concurrently with each other. So what can happen is that either the communication on the left side could happen, meaning that the middle process receives the name Y, or the communication on the right side could happen, meaning that it sort of continues on with the rest of its actions after the output, which in this case is nothing, and the input process receives the name Z. Cool? Let's go back to this. And we'll get into, so right now we've described the syntax of the PyCalculus. So we've described like how you write a valid PyCalculus program, but we haven't, and I've sort of given you an intuition of what these symbols mean, but we haven't really like formally defined those symbols yet and what it means to actually like execute and reduce. And so we'll get into that next week. So I don't think we have time to go through all these examples either. Let's go through a few of them. So this is a little game that I made up called Am I a Process? Yes or no? And if I am I normal or am I not normal? So any thoughts on this first one? Am I a valid process and am I normal?
I would say that yes, I'm a process, and yes, I'm a normal process.
Yeah, that's correct. Awesome. Because we've just used...
Well, we don't know what P is.
It doesn't matter what P is, right?
No?
Because it's a normal process based on this left lower equation.
Okay.
Yep.
All right.
So if P is not normal, doesn't that make the whole line there not normal, or it still can be normal?
No, it still can be normal because, so even if you have many things happening concurrently over here, and then you wrap all that up and you say, but now wait for this sender receive to happen before any action can happen over here.
Oh, yeah. I'm glad that came up.
Yep. Yeah, these examples are pretty important. This one here, bang n.
So yeah, it's not it's a process. It's not a normal process.
Yep, correct.
But I would have a question. I have a question.
Yeah, sure.
I understand like what's from the definition of what is a process or normal or versus not normal, or at least I think so that I understand. But what, like in a practical sense, what's the difference between normal and not normal process?
So in a normal process, a communication can't happen. So in a normal process, you don't have any reductions of a normal process. Not normal processes can have reductions.
Okay. But
So there's no interaction within a normal process, but there is interaction between normal processes.
Yes.
Yeah. Right.
Okay, so how come this second example is not normal?
So it is not normal because it is constructed using this right here, this notation, this bang p, and we have this bang p. This is a not normal process.
Okay.
So this one right here, we have a process, and we are adding it to another process. We have one process that may or may not be normal added to a process that's normal. Any thoughts on this one?
It's also a normal process, right? It doesn't matter whether either one of them are normal, then the sum of both should be normal.
So it's actually not necessarily a valid process construction because to construct a normal process with to use the addition to construct another process, both of the processes have to be normal. And we're going to go through two more right now. So n in parallel or concurrently with m.
One second, Jake.
Yeah.
Jake?
Mm-hmm. Yes.
Okay, cool. Acoustically, I didn't hear it. You cannot make an addition with, you can only make additions with normal processes. Did I understand it right? Or?
Yes.
Okay, good, nice. Thank you.
So the thought there is when you do the addition, both P and N in this case are waiting to receive some kind of communication, right?
Or waiting to send some sort of communication.
Okay. Waiting to receive or waiting to send. And that means that they're both of the form like your top line there. Prefixed with something. So that's why they both have to be normal. Is that the idea?
Yeah.
Okay, cool.
You know, in the other book, Sigiori, I don't know his name. I don't know the names. I forget their names. He calls the normal processes. They call the normal processes summations, and so the language actually gets split out so that it calls them out even more distinctly. Just
yeah.
You know.
So
it is an important process. I actually going through this has really been. It's exactly right. It means that Joshua, what you said is exactly right. That in a summation, all of those processes are waiting to either send or receive. That's exactly right. And if one can send or receive, then that's the one that wins, and it will move forward. That's awesome. Yeah.
Okay. This here, we have two normal processes. We're putting a bar in between them. This is a process. This is not a normal process. And then we can also put a bar in between normal processes and not normal processes because, normal processes are just a type of process. There's a couple other examples over here that I thought were interesting. I guess, let's see, what else? Yeah. Are you guys okay with running like 5 or 10 minutes over the 45 minutes that I thought? What happened if anyone isn't? Speak up.
I would have to bail, but don't want to hold back the group.
Okay, sounds good. All right. We can go over this later, Carl, if you want to as well. So here's another process. Any thoughts onto whether it is a valid process and if it's normal or not normal?
Seems like you'd have to know the associativeness of the replication, right? I don't know. I mean, does it go across the whole thing?
Yeah.
Or
I was imagining it would only go up to right after the P.
Oh, my screen is okay. Oh, okay.
So this is the case like we've had, similar to the case that we have. Let me try to. The other addition that we had, which wasn't a valid process, because on the left hand side here we have this exclamation mark, which creates a non-normal process, and then we're trying to add it to a normal process, and that's not valid. So here we're sticking it's the same thing as before, but we're sticking a prefix in front of this bang operator for the process on the left-hand side there. So thoughts on this one?
So now you've made the thing on the left side of the plus sign normal, which means we can add it to the thing on the right side.
Yep. And in result, we get a normal process, because the result of addition is always a normal process. Here's another one. So here, instead of like a dot P, I've used a dot 0, or yeah, that should probably be the empty set sign. I'll try to fix that as well. So this is another not normal process. This is a valid process that is not normal because it's two things running in parallel. And then here, everything before the dot is the same, but then I've added sort of parentheses around the parallel thing over here, and this was just supposed to represent. So the result of this is that this is a normal process, and that's because we have essentially prefixed now with this dot this whole not
Jake,
this whole not normal process on the right. Yeah.
There's nice. There was some window in front. I couldn't see. Okay. Nice.
Oh, okay.
Thank you.
Hey, Jake, what's the significance of having multiple names before the dot?
So yeah, actually, I probably should have put dots between those as well. So here is a send on a name, then declaring a new name X, and that sort of doesn't really have a step action associated with it. And then we have an input action, and then we have the stop process. So you sort of, it's chaining together multiple inputs and outputs, essentially doing like pi.p, and then the result of that's a process, and then we put another pi dot in front of that, now p. So yeah, I should put dots in between those.
Thanks.
Cool. So in summary, here are our process constructions. So this is everything that we just went over. So the nice part about the summation notation, and then defining that if you have the empty sum, the sum of zero, that's the stop process, is it means that your definition of process doesn't need to sort of, the whole definition of normal process is contained within that line, and you don't really need to talk about sort of productions of normal processes and productions of other types of processes. So that's one convenience of the summation notation. Any questions about the syntax of the language here? Or what questions do you have?
Okay.
Yeah?
The I equals 0 goes to P.
Oh, yeah. So this is saying that when this summation, this like label set that you have is the empty set, P is defined as the null process. So when you have the addition of,
Sure, it has to terminate.
Yeah.
Yeah, I think that's the way I read it.
Well, yeah.
They terminate with the null process is the way I see it.
Huh? So I guess the arrow isn't really getting at any definition of reductions at all. It's sort of just calling out that those two lines are associated with each other. And all it's saying is that.
Okay, no, sorry.
Yeah.
If there's nothing in the set, then P is defined as the inactive process. Okay.
Yeah, exactly.
Got it.
Right. So you could definitely write a program that doesn't reduce. That's still a valid process.
Yeah.
Okay. So up next, if we continue these sections and if we find these valuable, there's a more formal definition of the behavior of these programs. So right now we've just sort of defined the syntax, and I've given you ideas of, this means communication, but then we get into like, what does that actually look like formally? And then things that we can prove about our programs that have this type of structure. And then examples of programs that do interesting things. As for like explorations or homework assignments that you could take with you, here's some ideas that I have. And the way that I'd like to see this happen, so I'm not getting paid for doing this right now. I'm just sort of doing this in my free time, just because I'm interested in doing this. And what I'm hoping is that if this collaborative learning process receives some sort of funding, or if these materials turn out to be valuable in the future, and someone either is paying me to teach them or is paying to use the materials, that anyone who sort of helps me create them would also get paid. And I'm going to use a sort of software license that Glenn has been thinking up in order to do that. So if you're interested in like doing any of these explorations and doing them with other people, I'd ask that you record the time that you spent on it and your requested compensation, and then we'll have a repo somewhere where I'm going to put all this information, and then if I accept your pull request, essentially I'm also accepting the value that you place on it and making a commitment to, if there's any revenue that gets generated from this material, that some of that would go to you until that limit that we've set and agreed upon is met. And I'll let Glenn talk a little bit more about that license thing in a little bit. So here's some of the explorations that I think would be interesting. Create more of those am I a process, and if I am I normal questions. I covered what I thought were some interesting examples, but there's probably some more interesting examples or confusing examples out there. So Glenn has also written a JSON Pi interpreter in .NET, and you could use this to run examples from section 2.2 or some other examples that you create. Create more interesting examples. Find other process calculi or variants in the pi calculus and record their differences. So this is just one presentation of the pi calculus. There's like the asynchronous pi calculus, the non-asynchronous, the synchronous pi calculus. There's, the polyadic pi calculus will be presented later. And then there's some sort of forms that are alluded to in the paper that are a bit different than the presented form. Learn the lambda calculus. Teach me about the lambda calculus. That'd be awesome. Like a lot of the language definition tools like K-Framework, a lot of their tutorials sort of start with the lambda calculus as like defining lambda calculus languages to sort of help you learn the tool. And so to learn the tool, I would need to learn lambda calculus and then do that, which I think I'm going to do, or find a better tutorial out there, a different tutorial out there. And then so there's all of these cool like language definition frameworks, language proof assistance, and it'd be fun to, I think, to sort of define this pi calculus or use this pi calculus in these tools and frameworks. So BNFC is one way that you can sort of define a language. That's how Erlang is defined. K-Framework is sort of if you define a language in the K-Framework syntax, you get an interpreter and a compiler for free, which is pretty cool. And you also get an interpreter or compiler for free that can be written in like many different languages. There's like a mod backend to it right now, the K-Framework interpreter. So there's also these proof assistant tools, which I don't know much about, Coke and Isabelle. And then, yeah, there's also like Dan Connolly has done some work with the PyCalc in Idris, which he just sent me last night. So it'd be cool to see that go further. I also have a friend who that I met here in Madison, who wrote his own sort of like language definitional framework called MOD. So it might be cool to see the pi calculus defined in that. Is there any question or any like interest in working on any of these? Yeah.
I was just looking at JSON Pi right before we started. I, for some reason, hadn't seen that link until today. Glenn, I am just now realizing you're the one who wrote it. I wondered if, it doesn't have to be now, but maybe at some point you could give us a quick overview, and then it's in F#, right? Does it require Windows, or how does that work?
So it runs on the .NET Core. I've yet to prove that it works on non-Windows, but I do plan to do that. It should. I plan to even post binaries so that people can just grab those and run it on any platform. Yeah.
Yeah, cool. I'd love to, get familiar with it. I'll try to dig into it this week. And yeah, if you wanted, or I'd love to, see your quick tour of it too. I don't know if that's something, Jake, you think we could spend time on or should spend time on.
Mm-hmm. Yeah, definitely. I was hoping, so that's kind of the end of what I have. I'm going to send out an email later with a request for feedback and sort of some more links for some of these explorations. If you're interested in any particular one, please send me an email, and then I'll make sure that like I flesh my ideas out for that a little bit more, or just hit the ground running. That's cool too. Yeah, but Glenn, could you give a quick little like overview of the JSON Pi thing, and then also maybe the how you envision the software license working? Sure.
On the JSON Pi, the README inside of on my GitHub is kind of that's like the best overview. It would let us run actually in the code. There's a project called tests, and these some of the first examples that we went through today are actually in there. You could run them as tests. And there's a REPL. I can go through that in the future. I think we don't have time for it here, but I would be happy to go through these examples in the REPL and run them together if we wanted to do that.
That'd be cool.
On the license, again, we don't have a lot of time to discuss that, but just just stepping back for a bit, in this area of these blockchain-based computers like Ethereum and RChain, when I look into it, I think that, okay, these systems are being used to transfer value, transferring tokens of value. And when we realize that it's just one world computer that's running all these programs, people start thinking of different economic models for business models for monetizing services and such. So like the Brave browser, for instance, wants to get us away from an advertising model and says, well, we can do micropayments at really inexpensively. And so the vision, as I understand it, is get away from the advertising model, get away from the models where our data is their product, so they give us something free, but they really just collect our data, and actually have us pay. That's my understanding. So when you take that logic and you say, okay, well, if people are going to pay, if there's a revenue stream, where does the revenue stream go? And so it seems, of course, it could go into a company that's been tokenized. So just like a normal company, and it's been divided into tokens, which either could be just like stocks today, and then the money comes from speculation on those stocks. Anyway, I hope to write this up in more, with a better explanation all the way through, but
on your new blog that you put on GitHub, right? Like you promised.
Yes.
On Markdown.
Yes. That's forming. Sorry, I've been writing the REPL all week, so I do plan to get to that. So just thinking through, if we are going to have micropayments, how do we manage that? So the idea of a contract, a new type of open source contract that says, well, if you've, I don't know if you can call it open source anymore because it's not free. It actually demands, as part of the license, some payment for to compensate those who contributed. But without, the hope that I have is that without forming necessarily a company, or if it is, it's a cooperative where those who contribute or even other stakeholders, those who consume, have rights within that project. So we can think of, so many of the services that we write today are, you can think of them as almost community services. You take ride sharing applications, you take applications for sharing our hotel space. I don't want to name brand names, but these things you could think of as protocols that are kind of natural to our human existence. People used to walk into a town and find out who was renting a room for hundreds of years. And it's true we've brought that into the digital space, but it's really kind of a common protocol. And when we start seeing these contracts that run on this global computer, if we share the code for those, we could imagine that we're really just as a people collaborating on how those protocols should work well for all of us. So there's going to be a revenue stream. How that revenue stream gets divided up is a question, and that's kind of the idea behind a different type of license.
And some of the aesthetics behind it too are sort of this idea that, at least kind of what attracted me partially as well, is this idea of valuing your time and saying that, okay, I value the work that I've put into this at X amount, and if I feel like I'm gonna state that up front, and if I get compensated all of that, then like it's free and open source, it's free to use. Like I'm done with my liability. So you sort of can develop these applications that don't keep taking a cut off the top. And
yeah, and yet like if you read GitHub's how do you make money in open source, it's, last time I read it, it was kind of like I couldn't go to my bank with that. There's no way I can pay my mortgage with what they are saying. So you basically do it for the joy of doing it, which I have no problem with people doing that. There's lots of things in this world we should just do for the joy of doing it. but it's kind of like when we look at a lot of the cloud services, they're just taking free open source software, putting it behind a paywall essentially, but with inside of a data center and charging for it.
Exactly.
So there's a huge revenue stream of running this open source software. It seems that it's going to those that set it up. There's a lot of work in that, but a lot of work to develop it as well. And it seems that if we developed it and paid for its creation, we're paying for gas and the network. That's the cost of executing it. And then if once those who created it are compensated, if we say, well, great, we can consider this something that the world owns and it can build on top of. I don't know, if we could get something in between completely open source and free and completely walled garden, rent it forever type of something in the middle is the idea. No idea if this is just no idea if we can form this legally or whatever. No idea.
Exactly. This is the stuff why I'm also interested in this whole blockchain space and like as a medium to run experiments. For these type of questions. How do you measure the different aspects of value in between the spectrum from completely free to the closed model we have today? Right.
Yeah. I mean, one thing to think that as we carry, in my mind, some sort of logical conclusions is that we will be able to write programs that meter usage. Essentially, that's what the cloud services are doing today. They count how many times we run a web method, and they charge because of that. It's a tiny, tiny fee, but that adds up, and that's how they charge. So we would be able, in our Erlang programs, to put a line of code in there that says every time it's executed, we charge a tiny bit of money. If that model even works, if we assume that it does, if it's open source, anyone should be able to just copy it, change that line of code to transfer the money to themselves rather than to the people who wrote it. And they can totally undercut the cost because they didn't have to do the creative work of writing the program. If this is my thinking, I hope I'm open to thoughts that say, no, your thinking is flawed here somewhere, but it would either undercut that model or people would have to obfuscate the code or do some other way of putting a wall around it. So what we're trying to think through is we like the open source of sharing and making it available for everyone, but we'd like a license that says you need to collaborate to share in this revenue model. So you can extend it and still share in the revenue, that type of thing. So that's what we're trying to work through. Did that do it, Jake?
Yeah, awesome. Thank you so much.
More details to follow.
Yeah, it's work in progress. But yeah, I'm sort of committed to this idea, and sort of as we're building this thing, I'd like to use the building of this education materials if other people are interested as sort of a test bed for these ideas.
Yeah.
Cool. Well, yeah, we went over by quite a bit. I was hoping it'd be 45 minutes. I'm allowing you guys to give feedback on the length and amount of content and all that in there. I also hope that we'd have a little bit more time for open-ended discussions. So I think for me, this felt like maybe a little bit too much content for one session, but I'm willing to hear feedback from others as well. So yeah, or if it's the right amount of content and you'd like to go for an hour and a half, I don't know, that's something I'd be open to as well. But yeah, thank you all so much for attending. This is really cool. I hope to continue learning collaboratively with you guys.
Yeah, thanks a lot, Jake. This was really helpful for me. Thanks for putting it on.
Thanks, Jake.
Awesome. All right.
Yeah, thanks, Jake.
See ya.
Ciao.
See you.